Okay, so like I was saying, these are the steps to any hypothesis test. You can read those. Next, these are the parameters. I already talked to you about them when we did the intervals. Next, these are the hypotheses. I already talked to you about them when we did the intervals. Here they are. Okay, so next, the assumptions. So the assumptions are the same like when we did the intervals. Randomization condition. Make sure you put 2 independent random samples. SRS stands for simple random samples. So if I ask you to type those up on your test, just type it up, 2 independent random samples. Assume that the samples are less than 10% of their populations. And then the large enough condition, just make sure that your number of successes and failures is at least 10 for your first sample. And then again, the successes and failures are at least 10 for the second sample. So that's the assumptions. Okay, now, this is the new formula for, this is the new formula for your test statistic. And again, if you have it in your notes, I wrote it at the very, very bottom. So to find our new z-score, which is called a test statistic, this is the formula that we're going to use. And I guess we'll just talk about it in a minute when we get there. And then finally, the last step is always to make your decision and conclusion. We're still going to be doing the same thing we did before. If your p-value is very small, or at least less than the significance level, you reject the null hypothesis. And you say there is evidence that the alternative is true. Now, if the p-value is large or at least greater than your significance level, then you do not reject the null hypothesis. And therefore, there is not enough evidence to show that the alternative is true. So I guess we can go ahead and start an example. So number 1, a couple of years ago, I made my classes like write up their own examples because I was tired of like depressing examples like arthritis and cats dying and stuff like that. So anyway, so this is what my class came up with one year. In 2015, Mateo Garcia learned how to walk. That was true. His father, Mr. Garcia, has recently been having trouble staying upright after long nights at the bar. Okay, that's not true. But Mrs. Garcia jokingly argued that Mateo could stay upright longer than Mr. Garcia when walking across the room. So then Mr. Garcia protested that and argued that he could walk better, I guess. Let's get to the math. Okay. In a random sample of 495 of Mr. Garcia's walks, he fell over 81 times. So that's going to be your first sample here, 495. And Mr. Garcia fell 81 times. In a separate sample of Mateo's walks, 276 times, he only fell over 42 times. Thus, this data indicate that the proportion of times that Mateo falls over is less than the proportion of times that Mr. Garcia falls over. And we have a significance level there. So I guess let's run through the test together. And step 1, define the parameter. So you need to do either P1 equals P2 equals, or you can just put them together as P1 minus P2. And depending on the order that you write it, that's how I subtract. So I wrote P1 minus P2 is the true difference between Mateo and Mr. Garcia. So I think that's the way I'm subtracting. I'm going to subtract Mateo minus Mr. Garcia falling over. So that's my first one. Again, if you're following along on the notes, we're right here, letter A, define the parameter. Okay, now you do the hypothesis by yourself. Write what is the null hypothesis and what is the alternative. And remember, you're trying to figure out if Mateo falls over less often than Mr. Garcia. So go ahead and write your hypotheses. Okay. Hypotheses. So I went ahead and wrote the null hypothesis is that the true proportions are equal to each other, or that the difference is equal to 0. The alternative, like I told you, I let P1 be Mateo. So Mateo falls less often than Mr. Garcia. So I did P1 is less than P2. Or that the difference between P1 minus P2 should be less than 0. You can choose to write it either way. You don't have to do both. Now the conditions, I guess we'll just read them. They're all on your notes there. Assume we have 2 independent random samples of Mateo's and Mr. Garcia's walks. Assume that the samples, so the 276 and the 495, are less than 10% of the walks that Mr. Garcia and Mateo can take. The large enough condition, again, this is supposed to have a little hat here, but I forgot to put the hat on the PowerPoint. You're supposed to do N1 times P hat 1. So the number of successes for Mateo and then the number of failures. So falling over was our success here because that's what we're looking for, the proportion of falling over. So that was 42 times he fell over for Mateo. The complement was 234 because remember the sample was 276. So those are at least 10 for sure. And then for Mr. Garcia, again, it should be N2 times P hat 2. So that was the 495 times however many times Mr. Garcia fell over, which I think it was 81 out of 495. So that's just 81 times he fell over, and therefore 414 times he didn't, and the sample is large enough. If you have any questions at any time, just make sure you just let me know. Okay, now we get to the actual math. We are going to find the test statistic, and then we're going to find the p-value. So to find the test statistic, you have to use the formula, and then you're going to have to memorize it. So this is the formula for the test statistic. Z equals P hat 1. So we need to find the proportion of times that Mateo fell over, minus P hat 2. So find the proportion of times that Mr. Garcia fell over. We're going to substitute him. Minus P1 minus P2. I think I skipped that slide over here. Wait, is it this one? No, I don't know where it went, but I think it's on your notes. Let me find it. Oh, yeah, here it is. Okay, so this is the formula. Make sure you memorize it. All right. I already told you P hat 1 is the proportion of times Mateo fell over. So substitute that in. Minus P hat 2 is the proportion of times Mr. Garcia fell over. Substitute that in. Okay, now minus the true difference between P1 and P2. Okay, technically we don't know the true proportion of times that Mateo falls over overall. Neither does Mr. Garcia. We don't know that. But because in our null hypothesis we're assuming that they're different, since we're assuming that they're the same, we're going to go ahead and just plug in 0 here for the difference between P1 minus P2. So I put the note here, where P1 minus P2 is equal to 0, because that's what the null hypothesis was. We assumed that the difference was 0. We're assuming that they fall over the same amount of time or that there is no difference. So 0. Okay, now here's another hard thing to explain. Okay, this thing called PC or P hat C, it's called the pooled proportion. And I think I talked about it up here on your notes. I did. So I'll just read you what it says. Let me go back. There's a slide for that one. Okay. Since you're assuming that the null hypothesis is true and that the proportions P1 and P2 are the same, then for this reason, we're going to average together, or what's called pool, the 2 sample proportions into one single parameter. So basically it's called P pooled. You take the weighted average of the first proportion plus the second proportion. These are the formulas of how to get this weighted average. You're basically going to take the number of successes in both of the samples and divide it by the sum of both of the samples. So let's try it on this example here. Okay. So here are the substitutions. I guess let's go ahead and write them down so we can talk about them. 42 over 276 is the proportion of times Mateo fell over in the sample. So P hat 1. Minus 81 out of 495 is the proportion of times Mr. Garcia fell over in his sample. So P hat 2. Minus 0, because like I told you, you assume that the difference P1 minus P2 is 0. So that should always be 0. divided by the square root of this thing called PC or P hat C. That stands for the pooled proportion, or in other words, it stands for the weighted average, like the average between the two sample proportions, P hat 1 and P hat 2. So here's how you find that weighted average, and you're supposed to show your work on all of this, even though this year the test is just like fill in the blank or multiple choice. You are supposed to show all your work here for the AP exam. So this is the formula on how to get the P pool, like the sample proportion that was pooled together. You take the number of successes of both of the samples and you divide by the sample size, the sum of the two sample sizes. So in other words, here we go. You take 42 plus 81. Those are the number of successes in each of the two samples. Then you divide by the sum of the sample sizes, so 276 and 495. And that's how you get, or that's how I got this, what's called the pooled proportion. You need to use the pooled proportion in your formula here. So I'm going to put 0.1595 right here, or I rounded 0.16 times this complement. So this complement. And then times 1 over the sample size of the first one, so 1 over 276 plus 1 over 495. And now that's going to give you your Z star. So I guess we can just practice it to get it. Get your calculator and just practice it at least once. And then, of course, I'll show you how to do it on the actual calculator. So let's just practice. Marteo, 42 out of 76 minus Mr. Garcia, 81 out of 495 divided by the square root of 0.19. Let me just use a rounded number. I think I'm using a rounded number, but that's okay. In a minute, we're going to use the calculator for like the exact number. So I think it was 1 over 276. Over 495. Everything looks, I feel like it looks good. Let's see. So I'm getting a Z-score of like negative 0.416. That sounds right. That looks right. Okay, we're still going to confirm in a minute with our with the calculator by using a 2-proportion test. But for now, I'm going to go ahead and write that down so that you show all your work. So Z is negative 0.42. I rounded it. And then just like before, you need to know how to calculate p-values. So to get the p-value, you're either going to be looking for the probability that a z-score is greater than negative 0.42, so your answer, or less than negative 0.42. And that depends on that alternative hypothesis. So remember, if the sign here is less than, then you need to find the area less than negative 0.42. If the sign here was greater than, you should have found the area that was greater than negative 0.42. And then remember that the one that is not equal to, you just have to find it one way and multiply by 2. But right now, my hypothesis, the alternative hypothesis was less than. So let's find less than negative 0.42. The way you would find less than negative 0.42 is with your calculator. You would do normal CDF of negative infinity to negative 0.42. And then since that's a z-score, 0 and 1 are always the mean and the standard deviation for all z-scores. So again, one more time with the calculator, you would do menu, distributions, normal CDF. I want less than negative 0.42. So that's my p-value. That's a pretty large p-value. So I guess copy down the work because you are supposed to show all your work, especially if you're going to take the AP exam. So show the formula, show the substitutions. I think for my test on Tuesday next week, you're just going to like either multiple choice or I think it's fill in the blank. You're just going to fill in like negative 0.42. Follow the directions. Same thing with the p-value. I think it's either going to be multiple choice or fill in the blank. So you would just put 0.338 or just follow the directions as to how to type your answers. And but technically you're supposed to show all of your work. But I'm not going to check this year. Okay, so now let me go ahead and show you how you can just do this on the calculator as well. It's called a 2 proportion Z test. See if you can find it on your own. 2 proportion Z test. 2 proportion Z test. Okay, so calculator. Menu. Statistics. You have to go to the stat test. These are all the tests that we're going to do this year. We've already done the 1 proportion Z test. That was last unit. Now we're doing a 2 proportion Z test for this unit. And then next unit, we're going to do the rest. Well, the top ones. But choose the correct one. 2 proportion. It has to say proportion. Okay, now type in everything. So P1 was Mateo, 42 out of 276. The second sample was Mr. Garcia, 81 out of 495. And then here, change your hypothesis to match the scenario. So you wanted to know if Mateo falls less. So P1, which was Mateo, less than Mr. Garcia. And here's a bunch of stuff that will give you. I want to show you what the ones you need for sure. For starters, here's the Z-score, the test statistic, negative 0.416698, so negative 0.42. So we did do it right. Next one here is the p-value, the 0.338. So that's what we got. Okay. Then I also want to show you where you can find the pooled proportion. Remember that we pulled it together? So P hat 1, that's Mateo's proportion. P hat 2, that's Mr. Garcia's. Okay, the third one here, the one that just says PC, that's the pooled proportion. So that's the 0.1595. That's the pool proportion. So now you know where to find it in case you forget the formula. The calculator will show it to you right there. And that's how you do your step 4, making your calculations. Let me give you a minute to try the rest of this, which says, oh, actually, let's just keep going with the wording recipe of a p-value and then decision and conclusion. And then that would be it. So letter F, interpret the p-value. It's a wording recipe. I don't think I included it in these notes because, I don't know, I just forgot. But the wording recipe is the same for the p-value as it was before. You would say, if HO is true, the probability of observing the given statistic is p-value %. So again, it was a wording recipe from your last hypothesis test. So write it down if you want to have it. It's the generic one would be, if HO is true, then the probability of observing the given statistic is p-value %. So that's the wording recipe. If HO is true, the probability of observing the given statistic is p-value %. Or specifically in this situation, if Mr. Garcia and Mateo fall over the same amount of time, so if they're equal proportions, the probability of observing the results that we got are about 33.8%. So that's pretty large. So we're gonna assume that the null hypothesis was true. So see if you can go ahead and do your G and H and see if you remember. Your decision should be either I reject the null hypothesis or I do not reject the null hypothesis. And that's just based on your p-value. And I think use 5% significance, I guess. So 5%. Hopefully you said, I reject no, you said I fail to reject, right? Yeah. I do not reject the null hypothesis because a p-value is more than 5%. So decisions are always about your null hypothesis. You either reject or do not reject the null hypothesis. Here we say, I do not reject the null because my p-value is more than 5%. And since you didn't reject the null, that means that you don't have enough evidence for the alternative. Or in other words, you can just answer the question. The question the original question was like, does this data indicate that the proportion of times Mattel falls over is less than the proportion of times Mr. Garcia falls over? So no, I guess the 1-year-old falls over just as much as Mr. Garcia when he goes to the bar, but he doesn't. And that's how you do the test. So now I'm going to stop the video. Now I need you to try number 2. I'll leave you. Okay, so again with that contest, number 2 was in Spanish. So if you don't speak Spanish, I translated it to you right here. Okay, let me stop my video. Try number 2, and then I'll show you the answers in a minute. Okay, so here's the answers for that second example. Wait, are the answers here? Oh, yeah, they are. Okay, so letter A, define the parameter. It looks like I did true difference in proportion in Mr. Garcia and Mrs. Garcia. So I went ahead and did Mr. minus Mrs. That's how I subtracted. So P1 is the Mr. and P2 is the Mrs. State the hypothesis. P1 minus P2 is equal to 0. So there is no difference between us. Next one, alternative hypothesis. P1 minus P2 is less than 0. So we want to test to see if the proportion of A's in Mr. Garcia's class is less than the proportion of A's in my class. And it was. Oh, my grades were always better. Okay, anyway, check the conditions. I don't think I wrote all the conditions. So you would just say, assume we have 2 independent random samples. Assume that the 165 or 167 and 120 is less than 10% of each population. And then your number of successes and failures have to be at least 10. So yeah, 84 is definitely at least 10. 167 minus 84 is going to be at least 10. And then same thing with 72 is at least 10. And then 120 minus 72 is definitely at least 10. So sample is large enough. The conditions are good. Find the test statistic. Okay, this is where I told you that although you do have the calculator that can find all of this for you, you are supposed to show your work, I guess, on the real AP exam. Or if I do ask you to show your work on a test or something and take a picture, this is what you would have to show. Show the formula. Z equals P hat 1 minus P hat 2 minus the true parameters P1 minus P2, which will always be 0, divided by that PC pooled and then the complement times the samples times 1 over the sample size plus 1 over the second sample size. So if you substituted everything, P hat 1 was Mr. Garcia. So 84 out of 167 have A's minus my 72 out of 120 that have A's minus 0, which is, this is always 0, divided by the pooled proportion. So one more time, to get that pooled proportion, you're supposed to add the number of successes on both samples and then divide by the sum of both sample sizes. So if you do 84 plus 72 all over 167 plus 120, you'll get that. And then you just plug that into the sample proportion pooled times the complement, and then you have the sample sizes there. So this is the answer that I got, negative 1.6. Remember that you could also just get your calculator and try that 2 proportion thing. So hopefully you tried it. And then if you do use the calculator, it gives you your test statistics, so negative 1.6. It also gives you the p-value, 0.05. And then interpret the p-value. Like I said, that's the wording recipe. You would say, if the null hypothesis is true, then the probability of observing the given statistics is about 5%. Let me see if I have it. This is all the same thing again. Okay, so I put, if really the proportions of A's in Mr. Garcia and Mrs. Garcia is the same, then the probability of observing the given statistic is about 5%. So now, I mean, 5% is like on the borderline, but I think for this example, I told you to use 10% significance. So if you read the notes, it says it on your notes right here, use 10%. Just because I wanted you to have like a different conclusion than example number 1. So let's use 10% for your significance. So 10% for the significance. So therefore, My p-value is less than 10%, so I reject the null hypothesis. Since I rejected the null hypothesis, there is evidence that the proportion of A's in Mr. Garcia is less than the proportion of A's in Mrs. Garcia. Or I think you can just say there is evidence that I'm just a better teacher. So you can say that. Mr. Garcia and I taught Algebra 2 together for a very long time. And my kids always did do better. Maybe I just have smarter kids, or maybe I'm just better. I don't know. So there it is. There is evidence that the true proportion of A's in Mr. Garcia's is less than Mrs. Garcia's. Pause the video.